there, welcome back to Think Tank Online Learning. I hope for support in form of likes, comments, and share. Okay, so I'm given a problem. Suppose f is equal to ci, yx, and yk. Okay, and c is the intersection of the plane z equals to 2x plus 2y minus 1, and the paraboloid z equals to x squared plus y squared. And we want to verify Stokes theorem. Okay, so this is formula for Stokes theorem. So if we want to evaluate, Stokes theorem, we're going to evaluate the double integral of the curl. Okay, so curl of the vector function. So this is vector function. Okay, want to evaluate the curl of f, then n is the normal. Okay, ds, and this is equal to FDR, the double integral, the integral of FDR. So this is the work done through a closed path. Okay, through a closed path C. Okay, so I'm going to first do the Stokes theorem first, then I'm going to do the line integral after. Okay, so we have our equations. F is equal to ci yx j plus yk. Then we have z is equals to 2x plus 2y minus 1. Z is equals to x squared plus y squared. Okay, so I'm not going to graph these equations, but you know that this is a cylinder, because if we equate equation 1 to equation 2, we're going to say equation 1 to equation 2, equate equation 1 and 2. Okay, so by equating this equation, we know that z is equals to x squared plus y squared is equal to 2x plus 2y minus 1. Okay, so let's just collect like terms. So we're going to say 2x plus y squared minus 2y, so it's negative 1. And now we're going to complete the square, divide this by 2, then square the answer obtained here. So negative 2 divided by 2, it's 1. Then I'm going to square 1, so same as x squared minus 2x plus 1, and I'm going to take away that 1. Okay, y squared minus 2y plus 1 minus 1 equals to negative 1. Okay, so I'm going to see, going to have a circle that is its center 1 1 and a radius of 1. Okay, then after doing that, we want to find the curl. So now we know this is a circle, it's a full circle, so we have our range for theta and for r, so the radius is 1. Okay, so now I want to find curl. Okay, so the curl of f is equals to I j k. Okay, so partial x, partial y, partial z. Then what is the I component? Fz. And what is the y component? It's yx. And what is the k component? Which is equal to y. Okay, what is the k component? Okay, then now I'm going to find the curl. So the curl is equal to, okay, the curl is equal, I'm assuming that you're familiar with finding the curl. Okay, so the curl is equal to I plus j plus k. Okay, so this is the curl. Okay, let me write it. Yes, this one. Okay, so we have the curl. but we don't have the normal. Okay, so what is the normal? So the normal, what the easiest way of finding the normal, I'm going to say, let's say I have another function here, I'm going to call it g, and g is the function that includes this plane in this cylinder. Okay, so g is equal to, okay, so this is z. If you look at this equation, you're going to see g is equal to x squared plus y squared minus, okay, minus 2y minus 2x plus 1. And the formula for finding the normal, okay, n is equal to the gradient of g over the magnitude of g, and that is equal to g. That is the formula for normal. Okay, so if you want to find the gradient, okay, so the gradient, we're going to just find the partial derivative of x, y, and z. Okay, so if we do that, let's find the partial derivative of g here. So if we differentiate with respect to x, that is the I component, we're going to get 2x minus 2, okay, I, plus we're going to find with respect to y, it's going to be 2y minus 2j, and for k it's 0. Okay, what about the magnitude? Okay, so the magnitude is going to be, I'm going to square the y component, the x component, the z component, so it's going to be 2x minus 2 squared plus 2y minus 2 squared plus 0, or under square root. Okay, and I'm not going to simplify it. Okay, now I want to find the ds. Okay, so ds is just equal to the partial derivative of g with respect to x squared plus the partial derivative of g with respect to y squared. Okay, we don't have z, so it's like we're in xy plane, so there's no need to say plus 1 because we don't have z here. But if we add z, we're going to say plus 1. Okay, so this is equal to this one. Okay, so this is equal to the square root of 2x minus 2 squared plus 2y minus 2 squared. Okay, so now we're good. This is a circle of radius 1, so I'm going to graph a circle here. What is the center of the circle? The center of the circle is 1, 1. Okay, so I'm assuming this is the circle 1, 0. Okay, and I want to find the range for theta, which is the angle, because I'm going to use polar coordinates. Okay, I have a cylinder, so I'm going to use cylindrical coordinates. So theta is from 0 pi to 2 pi. Okay, so theta ranges from 0 to 2 pi. R, which is the radius, from 0 to 1. So now we're good. Going to say the double integral for theta to 0 to 2 pi, then r 0 to 1. Okay, then what is the curl? So this is the curl. Okay, so it's a dot product of the curl and the normal of the vector. Okay, so the curl is I plus j plus k. Okay, what about the normal? Normal is 2x minus 2i plus 2y minus 2j over magnitude, which is the square root of 2x minus 2 squared plus 2y minus 2 squared we have ds. ds is this one, so this is ds 2x minus 2 squared plus 2y minus 2 squared. Okay, so the reason why I didn't simplify here is it's because I know ds is going to cancel the magnitude of g, of the partial derivative of the gradient of g. So here you can easily cancel, as you can see, this one into this one, just 1. Okay, now suppose I don't have space here, I should have written r dr d theta. Okay. Okay, so I'm going to rewrite 0 0 1 0 1. Okay. So let me just say 1 1 1. Okay, so that is the curl. Then we have the gradient of g 2x minus 2 2y minus 2 and 0. Okay, r dr d theta. So this is equal to 2 pi 0 1. Okay, so this is same as we're going to this dot product 2x minus 2 plus 2y minus 2 plus 0 r dr d theta. Okay, since we're in polar coordinates, you know what is x. X is equals to r cos theta, y equals to r sin theta, then r squared equals to x squared plus y squared. So let us rewrite it in polar coordinates. Okay, 2x, that is 2r cos theta, but we have another r, so I'm going to multiply, so it's going to be 2r squared cos theta. Okay, minus 2 and minus 2 is minus 4. Then 2y is 2r sin theta times this r, so it's going to be 2r squared sin theta minus 4 dr d theta. Okay, then I'm just going to integrate with respect to r, 2 pi 0. So this is going to be 2r to the power 3 over 3 cos theta plus 2r power 3 over 3 sin theta minus 4r. Okay, so we have negative 2 and negative 2 times r, so this was supposed to be 4r. Then 4, if we integrate 4r with respect to r, it's going to be 4r squared over 2. Okay, 1 0. And now we're going to just say lower bound minus upper bound. So if we do that, we're going to get 2 pi 0. Okay, 2 over 3 cos theta plus 2 over 3 sin theta minus 2. Okay, the theta, and we're going to integrate with respect to theta. Okay, so if we integrate cos theta with respect to theta, so we're going to get 2/3 sin theta. Okay, and if we integrate sin theta with respect to theta, we're going to get negative 2/3 cos theta minus 2 theta. Put our limits 2 pi and 0. Okay, and now we know that cos 2 pi is equal to 1, sin 2 pi is equal to 0. So we're going to get negative 2 over 3, negative 2 times 2 pi, so that is 2 times 2 pi. Okay, minus negative 2/3 cos 0 is 1, sin 0 is 0, and so this is equal to negative 4 pi. And now want to go to the other side. Since I'm running out of space here, I'm going to use another page so that we can verify using line integral. Okay, so now want to evaluate the line integral of a closed surface. Okay, so this is line integrals in space, and I'm going to use parametric equations because I think that is the easiest way. So this is same as this one. So what I want to choose t as our parameter. After that, I want to write this theta function f in terms of t. Then after that, we can compute our integral. Okay, so what do we know here? We know that z is equals to 2x plus 2y minus 1. So if we just say r equals to x equals to r cos theta, okay, but now we don't want theta, we want t, and we know the radius of this cylinder. We have calculated it when we use the first method. Okay, so the radius is 1, so that means x equals to 1 cos t, because we're choosing t as our parameter. Y equals to 1 sin t. Okay, 1 sin t. Then z is equals to 2 cos t, that is 2x, plus 2 sin t, that is 2y, negative minus 1. Okay, and now so that means if you want to write r, vector rt is going to be cos t I plus sin tj plus 2 cos t plus 2 sin t minus 1. Okay, so this is c component, j component, and I component. Okay, so that means if we differentiate rt with respect to t, okay, so cos x is negative sin t I, then sin t is positive cos t j, then here it's going to be plus negative 2 sin 2 plus positive 2 cos t. Okay, since 1 is a constant, that is going to be 0. Okay, like this. And now I want to find f. I want to present f in terms of t. So this is z. What is z? We said z is 2 cos t plus 2 sin t minus 1. Okay, I plus with yx. Okay, so that is cos t sin t j plus what is the z component k, which is y, so that is sin t k. Okay, then let us find, I think it's wise if you find the dot product of f r t times r prime t. So this is going to be, for r prime t, I have I sin t cos t negative 2 sin t plus 2 cos t. Okay, what about f is 2 cos t plus 2 sin t negative 1 cos t sin t plus, okay, sin t. Okay, so this is the I component, I, j, and k. So what is going to be the dot product? Is going to be negative sin t times 2 cos t, so it's going to be negative sine t, negative 2 sine t cos t, okay, negative 2 sine squared t plus sine t, okay, plus cos t cos squared t sine t, negative 2 sine squared t plus 2 cos t sine t. Okay, so what are like terms? Okay, so as you can see, this and this going to cancel. Okay, unfortunately only those. So negative 2 sine squared t minus negative 2 sine squared t, so that is going to be negative 4 sine squared t plus sine t plus cos squared t sine t. And we said t is an angle, so that means t ranges from 0 to 2 pi since it's a cylinder. Okay, so that means I'm going to say b, I'm going to our integral upper bound, which is b, 2 pi, lower 0. Okay, so we're going to negative 4 sine squared t plus sine t plus cos squared t sine t dt. Okay, so here we have a trigonometry problem. Okay, so what I'm going to do, I'm going to split my functions. Okay, so this same as saying 2 pi 0 negative 4 sine squared t plus the integral of 2 pi from 0 to 2 pi sine t plus the integral of 0 to 2 pi cos squared t sine t. Okay, so I was supposed to say dt here, right? Dt here, dt here. Okay, so I'm going to use for the first part, so it's for 2 pi negative 4 sine squared t dt. Okay, we know that cos 2 theta, in this case I'm going to say cos 2t is equals to 1 minus 2 sine squared t. So that means if we make sine squared t, take it out of the formula, we're going to get sine squared t is equals to 1 minus cos 2t divided by 2 divided by 2. So this is 2 pi 0. Okay, since 4 is a constant, I'm going to pull it at 4 1/2 minus cos 2t over t over 2 dt. Okay, so this is negative 4 1/2 t. Okay, then if we integrate cos 2t, that is got to negative sine 2t over 2, but we have to divide by the derivative of 2t, which is 2 from 0 to 2 pi. Okay, and if we do that, we're going to get negative 4 pi. Okay, upper bound minus lower bound. Okay, and now we're going to the, okay, so if you are in examination and you know that you've done what you've done when you use Stokes theorem was correct, you should know that this integral you're going to get 0. Okay, so now we're going to 2 pi 0 sine t dt. Okay, so if we integrate sine t, we're going to get cos t. Okay, so it's negative cos t. So if you say upper bound minus lower bound, cos pi it's 1, cos 0 it's also 1. So this is going to be 0. And now we're going to 2 pi 0 cos squared t sine t. Okay, so if you have problem like this, okay, there's no need to use integration by parts, okay, to take long time, but what you can just think of substitution. Okay, so we have cos squared t and sine t. So if we say u is equals to cos t, okay, so if say u equals cos t, then du dt is going to be negative sine t, then dt is going to be du over negative sine t. So as you can see now, this is going to cancel, du and dt is going to cancel. Okay, so that means we're going to say 2 pi 0, instead of writing cos squared, we're going to say u to the power 2 sine t. Instead of writing dt, I'm going to say du over negative sine t. Okay, and now we have to integrate u squared. Okay, so it's negative u squared du. So this is negative u to the power 3 over 3. And we have our limits 2 pi and 0. And we know that u equals to cos. So this is equal to negative cos cubed 2 pi cos cubed 2 pi over 3 upper bound minus lower bound, negative cos cubed 0 over 3 cos 2 pi and cos 0 is equals to 0. So as you can see, we have shown that the integral c f dr is equals to double integral of the curl n ds. Okay, because negative 4 pi is equals to negative 4 pi. So that means we have verified Stokes theorem. Thank you for watching.